A baby's song, Rod Stewart, and your significant other's most sensuous voice. What do they all have in common? Perhaps a drop larynx, a 50,000-year-old mutation which makes you and me far more communicative than our chimpanzee cousins. This time on Science Without Walls. Information in, lots of it, from many different sources, through all of your senses, considered individually and in an integrated manner, resulting in perception, which further results in action. In most species, that action is instinctual, perhaps reactive: run, mate, eat, attack. But information need not only be taken in and analyzed. Information can also be produced and projected. Warning calls or sounds such as a rattlesnake or a bird trying to distract a predator. But even in the most advanced animals, the number of calls, the number of sounds appear to be very limited. Man, and perhaps dolphins, appear to be the only species that have really developed and utilized language. We have oral language, visual language, and written language. Why is it that man appears to be the most communicative of all species and appears to be the only species that is aware of past and future as well as present? Man is apparently the only species that is really aware of death and the only species that has developed a culture. Brain size, you say. We all have big heads and big brains. Maybe. True. Much of the brain of smaller mammals is used primarily for sensory and motor purposes. The sensory parts collect information, and the motor parts act on that information, generally through functions like muscle movement. There isn't a lot of brain left over for other things in the case of the mouse and even the cat. Non-motor, non-sensory parts of the brain are often called the association areas. Primates have some of that, but man has the largest known proportion of association area among all the mammals, and presumably among all species. Our very primitive ancestors appear to have had a relatively small brain volume. That didn't change much until 4 to 5 million years ago. There was obviously some major event that resulted in the selection for larger brains. Jared Diamond, a professor of physiology at UCLA, has written a popular book, The Third Chimpanzee. He suggests that, perhaps 5 million years ago, certain chimps left the trees and focused on the land, walking erect, leaving their hands free for many purposes, including the making of tools, signals, and perhaps for advanced communication. The increased use of the hands helped evolve larger brains to fully and effectively utilize those now freed hands. Much of our brain is devoted to our hands. So natural selection selected larger brains. The brain reached its peak, volume-wise, perhaps 100 to 200,000 years ago in our distant cousins, the Neanderthals, who apparently disappeared from the scene some 30 to 50,000 years ago. They appear to have gone extinct in spite of having even larger brains than you or me, about 1,400 cc's, 1.4 liters. There is apparently no record that they had language, and certainly not written language. Human communication and language may have begun about 50,000 years ago in what Jared Diamond and others call the Great Leap Forward. Something happened, and it wasn't brain size that apparently led to our language and communication skills. Humans speak. No other species really appears to have this ability. Although the Neanderthals may have had the brain capacity for speech, they may not have had the vocal equipment needed. To produce speech requires a larynx, a voice box, located low in the throat. Neanderthals apparently didn't have that. Newborns and very young infants don't have it either. It was probably a mutation that led the Cro-Magnon peoples, and perhaps others, to develop the ability to easily communicate orally, presumably giving them an advantage over their Neanderthal cousins and over all other species. The Neanderthals are gone. The Cro-Magnons are our immediate ancestors. The anatomical location and position of the larynx is very interesting. Young children have high larynxes because it allows a young child to swallow and breathe at the same time without choking. But having a high larynx restricts the kinds of sounds he can make. The human infant is not really capable of speech, though he or she can make a variety of noises. But as children get older, the larynx drops together with other anatomical and physiologic changes. Then speech, as we know it, starts to become possible. We do pay a price for speech in terms of the sharing of breathing and swallowing passages, and our tendency to choke occasionally. There is another reason why we may have developed the talents for speech and language, whereas our Neanderthal and earlier forebears did not. Neanderthals probably operated in very small groups or tribes, with apparently little interaction among those groups. Interaction among greater numbers, a larger community or society, requires communication. And with communication comes culture. Homo sapiens is a language-based organism. No matter where we are located, we develop language. There are some 6,000 different languages on the planet today. Language does not need to be precise. It's contextual. We fill in, we use facial expressions, mannerisms, body language in a smooth and coherent fashion with our oral communication skills to provide maximally effective communication. Just watch people communicate. Steven Pinker, an experimental psychologist and neuroscientist, has written The Language Instinct. He argues that our brains come with the equivalent of a hardwired language learning program. He and the others before him believe that language is a biological system and not just a cultural and learned skill. He and others feel that parts of the brain contain a language organ, allowing language to integrate with sensory information to provide a more comprehensive perception of our world. In fact, Pinker takes issue with Jared Diamond's Great Leap Forward idea. He seems to feel that Neanderthals, and even their ancestors, perhaps back for several million years, may have had appropriate vocalization skills. In fact, he argues further that vocalization and language characteristics originated in our brains a very long time ago. Pinker would argue that Elizabeth, the little scientist in Program 2, is not operating with a clean slate at all, at least not as far as language is concerned, but that she is already genetically wired for language, not for English or Finnish or Chinese, but for language in general. Babies will very easily learn one or several of the 6,000 or so languages on the planet when exposed to them, and will speak them fluently when their vocal apparatus has descended and matured, permitting them to form the sounds required. This happens roughly by their first birthday. After that first birthday, most of them no longer babble, they speak. Men and women can generate sounds over an incredible frequency range, from very low bass to extremely high soprano. Generally only 2 or so, but sometimes as many as 3 and even 4 octaves. Bobby McFerrin has a very wide range.
On KUED 7, you've got the best seat in the house for dance. Theater, film, music!
As do many sopranos, such as Barbara Hendricks. They accomplish this, as do you and I, by a very small larynx, a very small voice box, containing what appear to be just a few flaps of skin, but connected to muscles. They don't look particularly impressive, but it does a remarkable job. Watch and listen to a larynx in action.
Tall and tan and young and lovely, the girl from Ipanema goes walking, and when she passes, each one she passes goes, ah. When she walks, she's like a samba that moves so cool, sways so gentle that when she passes, each one she passes goes, ah.
As you've seen and heard, we generally use exhaled air to make sounds. In the words of Steven Pinker, quote, "Syntax overrides carbon dioxide. We suppress the delicately tuned feedback loop that controls our breathing rate to regulate oxygen intake to match the length of the phrase or sentence we intend to utter. This can even lead to mild hyperventilation, which is why public speaking is so exhausting and why it is difficult to carry on a conversation with a jogging partner." Unquote. The lungs are connected to the trachea, the windpipe, and from there to the larynx, or the voice box, which we call, from its outside appearance, the Adam's apple. The opening of the larynx is covered by 2 flaps of muscle tissue, called the vocal folds or vocal cords. The larynx is really a valve because vocal folds are highly versatile. We stretch and otherwise deform and control them by action of muscles. It's the frequency of their opening and closing that determines pitch. Listen. There's a lot more to sound, to speaking and singing, than just the vocal folds. There are all the chambers between the folds and the outside world, including the part of the throat behind the tongue, the volume in the mouth between the tongue and the palate, the position of the tongue, the openings of your lips, and the specific size and shapes of all of these chambers. And of course, you don't normally produce a single tone or pitch. We're not like a tuning fork. What you produce is a rich sound with many harmonics. In the case of the normal male voice, that may be centered at about 100 cycles per second.
Do, re, mi, fa, so.
Whereas in the female, it's pitched higher, around 200 cycles per second.
Do, re, mi.
There is a richness to the sound you produce. Some of those sounds are vowels, sounds where the air is not significantly obstructed in passing from the vocal cords to the outside world. A, E, I, O, U. But using your tongue and other outside structures, you can put barriers in the path of that air. And depending on how you do that, you achieve the various consonants. B, T, N, S, B, T, N, S. In the end, every sound is a combination of sounds, which you produce by the way you instinctually and effortlessly contort your anatomy, both internally and externally. The development of oral language and communication eventually led to written language and communication. Jared Diamond has written about that as well. He says there are 3 basic strategies for written language systems. The characters or symbols can denote a single basic sound, a whole syllable, or a whole word. Of course, the most common strategy in your world is the alphabet, which provides a unique sign, a letter, for every basic sound or phoneme, such as A, B, C, D, E. Chinese is an example of a language where a written sign stands for a whole word. But in addition to complex icon-based written languages, like Chinese, and complex alphabet-based systems, like English, there are very well-designed, structured, and simplified alphabet systems, such as modern Korean. Korean is probably the most logical and regular written language in the world today. It was proclaimed and implemented by Korea's King Sejong in the mid-15th century. A superficial look at Korean leads you to believe that it's an icon-like language, like Chinese. But it's not. It has an alphabet where the vowels and consonants are very different, and the various phonemes or letters are packaged in syllables. Although languages tend to fall into those three general categories, the 6,000 or so known languages provide an enormous diversity in oral and written communication forms. Braille is a special example. Here the characters are sensed and perceived by touch, allowing a print-like form of communication, sensed by touch rather than sight. Another special language is mathematics, the language of science and of many other fields. Mathematics is the language of patterns, of relationships, of numbers. Man doesn't speak or even write solely to communicate. Man often speaks or sings for private entertainment. There are those who say that speech is independent from language, that making sounds is different from communication. Don't you talk to yourself? Don't you sing for your own pleasure or your own release or relaxation? What's the point of talking or singing if there's no one to receive those signals? Some speaking, like much baby babbling, seems to be just enjoyment, recreation, entertainment. Pinker says that when there is no one around to talk with, people talk to themselves, to their dogs, to their plants. Most of us love to talk, and not just to transfer information. The sounds we make with our mouths and with our hands and body can cause new combinations of ideas, not only in our own minds, but in the minds of those to whom we are communicating.
Yes, I want to give. Oh, because your programs are wonderful. They're marvelous. Fabulous. Oh, yes, of course.
Written language is a form of visual communication. You are sensing images with your eyes and perceiving messages or information in your brain. You do similarly with oral language. You sense, you receive sounds, and your auditory brain system has attributed meanings, information, to those particular sounds. But it could all be visual. Jody, on the screen, is now signing what I am saying. You've seen signers before, translating information from an oral mode to a visual mode, so that the deaf can hear through their sight. There's been enormous interest, activity, and understanding of signing as a formal language in the last 20 or so years. Jody's communication is aided greatly by her gestures and expressions. We all use such expression, together with the oral information, to attribute meaning to things. Optimism, pessimism, anger, happiness, confidence. We can read all of those attributes into a message through gestures, facial expressions, and inflections. We often call it body language. Thanks, Jody. There are many other ways that life forms communicate and interact with one another. Most of us detect photons, their position in space, their frequency or wavelength, and of course their number, the intensity of photons reflected from various objects. Although we are exquisite at detecting photons, you and I cannot produce photons. Sure, we can invent and develop tools which do that for us, such as lights and television screens. We can redirect photons produced by those sources with the use of mirrors and optical fibers. But you and I cannot directly produce them. Other organisms can.
Here. He's trying to get away. your hand, Rush. Whoa, there he is. Oh, he flew away.
Fireflies have an exquisite system of producing photons. They use this unique signaling system primarily for mating purposes. Light produced directly by living things is called bioluminescence. A large proportion of deep-sea creatures are bioluminescent, producing light with which to see and communicate in that otherwise pitch-black environment. There are many bioluminescent organisms, including protists and bacteria. Bioluminescence is, in essence, the inverse of photosynthesis. Rather than taking in photons and making chemicals with that energy, bioluminescent organisms take chemicals which they have laboriously synthesized and use the energy in those chemicals to produce light. A good example is the protists that live on the surface of the oceans all over the world. These are marine phytoplankton. Phyto meaning plants or plant-like, and plankton meaning they float free in the ocean, unattached. Let's see some real bioluminescence. Since there aren't many fireflies and we don't have a marine aquarium here in Utah, it's hard to see living bioluminescence here. Fortunately, the Center for Integrated Science Education at the University of Utah grows these phytoplankton for research and teaching purposes. These are protists, about 1/5 of a millimeter long. They divide every 3 to 7 days or so, and they grow very easily in these recycled milk bottles. And if we look at them in the dark at night and scare the daylights out of them with a very hard shake, they respond with this beautiful blue light, marine bioluminescence. They don't produce the light all the time, only when they're agitated. And they don't produce it in the day because it wouldn't be very effective. It would be so hard to see in the presence of all of those photons coming from the sun, or in our case, from the room lights. Well, why do they do it? Apparently for communication. Maybe they're trying to communicate to a predator who is stirring up the water, telling that predator to go away. But that's just one of several hypotheses. Bioluminescence occurs in some 30 or more of the 100+ common phyla of biology. It's believed to be there primarily for communication purposes. Bioluminescence is communicating with self-generated light. Many animals, and even plants, communicate with chemicals. Animals like to mark their territory, claim territory by marking it with unique body odors, either from their urine or from special odor glands. These organisms have far more sensitive olfactory talents than you or I do. Their competitors, and perhaps their predators, sense and perceive those odors. There are many chemical languages in biology, made up of molecular messengers and associated information systems. One set of molecular messengers is called the pheromones. Edward Wilson, whose book, The Diversity of Life, taught us about biodiversity and extinction, is one of the early pioneers in animal pheromones, particularly in ants. It's only been in the last 20 or 30 years or so that we've had sufficiently sensitive and specific chemical analysis tools with which to begin to detect, measure, and understand the nature of animal pheromones. Simple organisms like insects can detect incredibly low concentrations of chemicals by means and mechanisms which are still largely unknown to us. Even bacteria communicate chemically, enabling bacterial cells to operate in ways which approach the complexity of multicellular organisms. It's now recognized that bacteria can aggregate in very special structures and geometries, which give them the appearance of functioning as colonies rather than as anarchistic, individualistic single cells. They apparently use special chemical messengers, perhaps special proteins which they secrete and which are then detected by other bacteria. Bacteria are incredible. Many bioluminescent fish make their light by inducing a special species of bacteria to grow in a socket of the fish anatomy called a photoorgan. The bacteria are so concentrated and so organized there that the light they produce is very intense. So intense that some fish are called flashlight fish. The bacteria which make up the light-emitting part of that photoorgan talk to each other through various chemical messengers. The bottom line, information can go out by a variety of means, but mainly these four: by light and other electromagnetic waves, by sound in longitudinal pressure waves, by gestures or body language, and by chemical concentration. In many respects, chemicals are the most versatile form of communication because there are literally millions and even billions of potential chemicals which could be used. If only we had the means by which to specifically recognize and detect them. You have a set of enhanced communication skills and talents that have been slowly selected over the last 4 million years. Use your senses, all of them, and your communication skills, sensitively, effectively, and responsibly. See you next time.
Tak ta jum ta jum ta tak ta jum ta jum ta ta jum. Di tak ta jum ta jum di tak naka kupanta di kita nagi chali. Ku tak janu taka ta di kita talang. Dong kita taka ta di kita taka ta lang. Dong kita taka ta di kita tak to. Tadi kita taka tadi kita taka tadi kita talang kata kadu. Tadi kita taka tadi kita taka tadi kita talang kata kadu. Ditlang taka duma kita taka duma ditlang taka naka tak dugu tadi kita taka dugu. Dugu tadi kita dugu. Talang dum kita taka dugu tadi kita taka dugu tadi kita dugu tadi kita taka talang dum kita taka dugu tadi kita taka dugu tadi kita dugu. Terkadang tadi tana tajunata demi taka terkadang tajam taka kita terkadang taka digini dugu tadi kita dugu tadi kita taka dugu tadi kita dugu tadi kita taka dugu.